Welcome everyone to the second video related to circuit analysis. In the previous video, we found the current through 10 ohm by applying nodal analysis. In this video, we'll try to find the current through same 10 ohm resistor by applying mesh analysis. Okay. So when we are applying mesh analysis, what we generally do is we first identify the number of meshes or loops in the circuit. For each mesh, we will allot a separate current. So for first loop, I am assuming the current as I1, and the current for the second loop, I am assuming the current as I2. Now, when you are applying the mesh analysis or loop analysis, we generally consider if you are writing the KVL equation for loop 1, we generally consider that current is the largest current, and the current in all the remaining loops as the smaller current compared to that current. So if you write the equation for first loop, when we are moving from negative to positive, we'll consider it as a voltage rise, and when we are moving from positive to negative, we'll consider it as a voltage drop. Okay, now if you observe, initially in the first loop, so this is the first loop. Initially in the first loop, we are moving from negative to positive in plus 10 volt. Therefore, I am considering this as plus 10 volt. And through resistor 10 ohm, only I1 current is flowing. Okay. That's why I am considering this as minus 10 I1. And through 30 ohm, two currents are flowing. One is I1 and I2. But when we are writing mesh equations for first mesh, we need to consider that current as larger current compared to all other currents. Therefore, we can consider it as minus 30 into I1 minus I2, because both currents are in opposite direction, and current I1 is considered as the larger current compared to I2. As we are moving from positive to negative, we consider it with the negative sign. And through 15 volts, we are moving from again positive to negative, so it is also negative. You will have minus 15 equal to 0. When you try to simplify the first equation, so 10 minus 15 is minus 5. When you send it to other side, it becomes plus 5. And for I1, the coefficients are minus 10 and minus 30. Therefore, finally it is minus 40 I1. And for I2, the coefficient is minus 30 into minus 1. Therefore, it is plus 30. So this is the first equation which is related to mesh 1. When you write the equation for mesh 2, again 30 ohm is common, but now we need to consider I2 greater than I1. That's why what you will get is from 15 volts. Through 15 volts, the I2 is moving from negative to positive. Therefore, we need to consider it as voltage rise. Hence, it is plus 15 and minus 30 times I2 minus I1 for 30 ohm, which is common for mesh 1 and mesh 2. Next, 20 ohm through 20 ohm resistor. So this is the 20 ohm resistor. Through 20 ohm resistor, the only current that is flowing is I2. Therefore, it is minus 20 I2. And through 6 volt, we are moving from positive to negative. So like this we are moving. Hence, we need to consider it as a voltage drop. Therefore, it is minus 6 is equal to 0. Now 15 minus 6 is 9. When you send it to RHS, it becomes minus 9. And the coefficient of I1 is minus 30 into minus 1. Therefore, plus 30. So 30 I1. And minus 30 I2 minus 20 I2 is minus 50 I2. So this is the second equation. Okay. Now, in order to find I1 and I2, I need to solve equation 1 and 2. Without using calculator, if you want to solve, we need to apply some techniques in order to solve two linear equations in two different variables, I1 and I2. Now what I am trying to write, I am just modifying the first equation as minus 4I1, because I am taking 10 common and sending 10 to other side. Therefore, it is minus 4I1 plus 3I2 is equal to 5 by 10 you'll get 0.5. Similarly, second equation I'm just modifying again. So taking 10 common, 3i1 minus 5i2 is equal to minus 0.9. So this is the second equation. Now, in order to get I1, I need to eliminate I2. Therefore, what I am trying to do is, I am just multiplying first equation with 5 and second equation is multiplied with 3. Therefore, and I am adding these two equations. So adding first equation with 5 and second equation with 3, adding both the equations. Now you will get first equation multiplied with 5 gives you minus 20i1, right, plus 15i2 is equal to 2.5. Next, second one, because we are adding, second equation is multiplied with 3. So 3i1 into 3 is 9i1 and i2. Here it is, I am multiplying it with 3, therefore it is minus 15i2 is equal to minus 0.9 into 3 is minus 2.7. Now when you add both the equations, plus 50 minus 50 plus 15i2 minus 15i2, both will get cancelled out. Minus 20i1 plus 9i1 is minus 11i1 is equal to 2.5 minus 2.7 is minus 0.2. Okay, now cancelling minus on both sides, I1 is equal to 0.2 by 11, multiplying with 10 on both sides, means in the numerator and denominator multiplying with 10, you will get 2 by 110. Now by cancelling you will get 2 ones, 2 55s. Okay, so this is the current in first loop, which is 1 by 55. 1 by 55. So current loop, current in the first loop is 1 by 55. Now through 10 ohm you got the same current, therefore the current is 1 by 55 amperes through 10 ohm resistance. This is the same current which we got when we solved the problem by using nodal analysis. In this way you can apply mesh analysis. I hope you got some idea about how to apply mesh analysis. If you have any doubts, please post them in the comment section so that in our free time we will try to answer them. Thank you very much.